Hello everyone, hope you're doing good and welcome back to my channel. Today I will be sharing the code for the day 22 of the October daily LeetCode challenge, and it's again a medium level question revolving around the topic of trees. Okay, so it's question 2583, kth largest sum in a binary tree. Okay, so the question is not the right way to name this question because it is not talking about the levels. Okay, this question actually deals with the levels of a binary tree. Okay, so what is the question? You are given the root of a binary tree and a possible integer k. Okay, if you see the inputs, basically you are given these things. And if you're new to LeetCode, let me tell you one thing: if you are seeing the root given like this, okay, in case of trees or graph, remember it's not the right way to imagine it. Just for the sake of easier way to present it, they're showing it like this, but in actual it will be a root like this. Okay, the root will be one of these nodes. Okay, and it will have a left and right child, which are not shown here. Okay, it is just easy to represent it for you. Okay, if you're not to lit code, you'll have to know this thing. That is the one thing that I want to tell you in the starting of this question. Okay, what is the question? The level sum in the tree is the sum of the values of the nodes that are on the same level. Okay, I will just show this also in an example, but let's complete the question first. Return the kth largest level sum in the tree, not necessarily distinct. If there are fewer than k levels, you have to return -1. This will become a edge case. Remember that. Okay. The two nodes are on the same level if they have the same. Okay, what are the level sums? Okay, first of all, let us see here. For example, 5 is at a level 0. Okay, because its distance from root is 0. Similarly, 8 and 9 are on the level 1 because their distance from the root is that of 1 edge. Okay, they are just 1 edge away from the root. Okay, so what is the sum of level 1 here? It will be 8 plus 9. Okay, it will be 8 plus 9. Similarly, coming to level 2, what are the level 2 nodes here? 2, 1, 3 and 7. Okay, why they are in level 2? Because the distance from the root is same, that is they are two edges away. Okay, what are the two edges? Either 5 8, then 8 and 1, or 5 9 and 9 and 3, like that. Okay, they are just two edges away from the root. That's why they are at the level 2, and their sum, that is the level sum of when level is equal to 2, is 2 plus 1 plus 3 plus 7. Okay, now coming to 4 and 6. Okay, they are at a level 3. Why? Because they are three edges away. So if you see here, they are saying the same thing. Level 1 is 5. Okay, as you can see here, let's see, instead of calling it level 0, they're starting from level 1. Okay, that is their way of telling it. But yeah, what I assume is that level, yeah, the root will be at the level 0, but anyway they are starting from 1. Okay, fine. Level 1 is this one. Level 2 will be 8 plus 9, which you have seen here. Level 2 will be 8 plus 9. Okay, let me zoom out so that you can see both things together. Okay, yeah, these things. Now coming to level 3. Okay, level 3 is here. Okay, 2 plus 1 plus 3 plus 7, and final level 4. Okay, as simple as that. Yeah, so this is what is level. Okay, what we have to return, the level sum I have explained to you. Okay, and when they are at the same level, what we have to return ultimately? Return the kth largest level sum in the tree. Okay, not necessarily distinct. If there are fewer than k levels, you have to return -1. Okay, so if in this particular example, if you see that saying k is equal to 2. Okay, so what we have to first do? First, you have to calculate the sum. That is the value of the nodes present in that particular level for all the levels. Okay, for all the levels. After that, what I have to do? Among these values, okay, among these values, I have to find out which is the kth largest value. Kth largest basically means that, for example, first largest will be 17 in this case. Okay, because that is the highest. Similarly, second largest will be 13, third largest will be 10, and the fourth largest will be 5. Okay, fourth largest will be 5. Okay, but here what you have to do? You have to do the kth largest. Here it is the second largest is 13, so you have to return 13. Okay, that is the basic idea. So if you see in this particular case, they're asking the first largest, that is the highest value of return. So now, since each one of this node is in a different level, that is, you can clearly see that all of them are in different level, so their sum will be the value of the node itself. So in this case, 3 is the value. You have to return 3. Okay, I hope you understood the question. See, we have first of all, what we have to do, we have to explore the whole tree, and then for each level, basically we have to collect the sum of all the nodes values present in that particular level. Okay, and then what you have to do, you have to basically sort it so that you can return the kth largest thing. Okay, for example, is the second largest, so this you have to return a second largest value. That is the sum of all nodes present at that particular level. Okay, which is the second largest. And one edge case is that if there are fewer than k levels in the tree, you have to return -1. This becomes edge case. We'll have to handle this also. Okay. Now coming to the solution. If you have been following my video, I'm damn sure that you will not require to see my video to solve it, because these things we have discussed very keenly in in multiple instances, in multiple videos. Okay, in for multiple solutions. Okay, if you have been watching my videos for, I'm damn sure that you will be able to code this part. Okay, so okay, let me zoom in. Yeah. Okay, so what I'm doing it here, Yeah, first of all, I'm defining a level sum. It is going to be a mapping in this particular case. What is a mapping? It will be storing a key and a value. Okay, it will be associating a key and a value, and the key will be in such a way that it is in a hashed way. Okay, the key is stored in a hashed way. That is, if I try to find search for a key in this, it will take over one time. Okay, then I'm defining it. Defs function. Yeah, I'm defining a defs function. Okay, so, as you might be knowing, if you are accessing any value that is defined outside of current function, you have to define it as a non-local. That I'm doing it here. Okay, what I'm doing, since it's a recursive function, I'm defining a base condition which will be stopping the recursion. Is this is this? Okay, if the root is none, you have to return it. As simple as that. Next, what I'm doing, I am filling the level sum in this particular node. Okay, what I'm doing, if the current level, remember how the function call will be like this. Okay, so by default it will be zero. You can also pass a zero here. Okay, let me do that also. Okay, you can also pass a zero here, but by default it will be zero. So that is when I'm passing the root, I'm also passing zero. Okay, that is the basic idea. So for each level, okay, let us say I'm visiting a node for the first time in that particular level. So level will not be part of the level sum. Okay, level sum is a dictionary. So level will not be part of that sum because I'm visiting a node in that level for the first time. So this condition will be true when I'm visiting a node for the first time in that particular level. So what I have to do, define the value. Okay, for the in the level sum, add a key for this particular level and initialize its value to root.val. That is the value of the current node. Okay, let us say I'm visiting a node which which is at a level which I've already visited before. So what will happen? This particular thing will be existing again. That is, the level key will be existing already in the level sum. Okay, that is, this condition will be false in that case. Okay, it will be already existing in the level sum. Okay, level sum dictionary. Level will be already existing in the level sum dictionary. So what I have to do in this case, I have to simply add the current root's value to the existing value. Okay, this is a shorthand. Basically, if you're new to coding, let me tell you this. This is a shorthand. What it means is level sum of level is equal to level, that is plus equal to, basically means that to this particular thing, to the value that is already existing this, I'm simply adding this. Okay, that is the basic idea. That is, level sum is equal to level sum plus root dot value. Okay, that is what I'm doing here. To the existing value, add this value. Here I'm simply initializing it. Okay, whatever with this previous value, it will be changed to this, but here I'm adding the root dot value to the existing value. Okay, apart from that, I am making two recursive function calls. Okay, first one for its left tree, the second one for its right tree. But remember, whatever is the level passed to me at this particular level, at the parent level, when I'm calling the child, that is when I'm going to the child, I will be increasing the level by one. Okay, I'm increasing the level by one. Okay, as simple as that. So okay, I will just print this and show you also at the okay. Okay, let me quickly do that first. If I just run this and show you how this looks. So yeah, if you see here, this how it will look. Okay, at the zeroth level, the sum is 5. At the first level, the sum is 17. As you can see, 8 plus 9 is 17. Similarly, at the second level, okay, the sum coming is 13. So we have basically 7 plus 3 plus 1 plus 2, which is 13. And at the third level, the sum is 10. 4 plus 6 is 10. Okay, this is how it will be looking. Okay, this is my level sum. Right? You are seeing the output of this particular print. Okay, yeah. So next, what I have to do, I am taking all the values. Okay, see, the dictionary will have a keys and the values. Okay, here I want only the values, so I'm taking the values and storing it in a list. Okay, storing it in a list. Okay, this is the this one. Okay, then I'm sorting it. Once I'm sorting, by default it will be, remember, in ascending order it will be sorted. Okay, so what I'm taking, say, I have to now implement this edge case. Okay, if the length of the level sorted sum, that is, if the number of levels in the current tree, it is less than k, then I have to return -1. Otherwise, I have to return the kth largest sum. Okay, that is the kth largest level sum. So I have to, because see, remember, this is sorted in ascending order. Okay, let me also print this and show you. Okay, so what I have to do, I have to return the kth largest value, that is the kth value from the last. In Python, wherever I'm passing, for example, sorted level sum of -1 means the last value. Sorted level sum of -2 means the second last value, and so on. So I have to return the kth last value here. Okay, if I can run this and show you. Yeah, if you can see it here, this is how it will look. Basically, after sorting. Okay, after sorting, only I'm taking the values here. Okay, these are the values I'm taking, and I'm storing it in a list. Okay, I'm taking all these values and storing it in a list. I'm sorting it. So this is how it will look. Because this question k is 2, that is, I've written the second last value. So I'm returning this 13. Okay, how to return this 13? I am doing it like this: sort level sum of minus k. Okay, that's how I'm doing it. Okay. So as you can see, like for all the test case, this, yeah, for both the test cases it worked, and I've already submitted the solution and it has been accepted. So this is one such valid solution for this. Okay, as you can see, this is already solved. So yeah, friend, that was this question for today. And yeah, if you have any doubts, please do let me know. See, I always believe that whenever a question is on tree, at least the people who are following me or my videos should be able to solve it, because I've uploaded multiple videos regarding trees, and I've shown you a lot of approaches, a lot of different problems or different difficulty levels in trees. And at least this part, this level part, I've shown you multiple videos. So at least if you have been watching my video, and if you have been really not watching it for entertainment purpose, but for a learning point of purpose, then I'm damn sure that you will be able to solve this question without any help. Okay, so that is the only expectation that I have. So yeah, fun, that was all for today. If you like this video, please do subscribe to the channel. This really gives a lot of motivation that yeah, my efforts are making change in someone's life. That's all I wanted to say. See you tomorrow. Thanks a lot.